Hello students, this is the third lecture of trigonometric functions. In our first lecture we have learned the principal solution of a trigonometric equation and some examples based on that. In second lecture we have learned the super 10 formulae for general solution of a trigonometric equation. Now in this lecture we will solve some examples based on those formulas. Let us see example number 1. Sin equal to 0. Here sin theta is equal to sin 0, so we will use first formula. Since sin of x plus pi by 5 equal to 0, also we know that sin theta equal to 0 implies theta is equal to n pi by first result, where n belongs to, as use here, we get x plus pi by 5 is equal to n pi, where n belongs to integers, and therefore this x is equal to n pi plus pi by 5. We can simplify this by taking this pi common, so we get n plus 1 by 5 out of bracket pi, or it can be written as 5n plus 1 upon 5 multiple of pi, where this n belongs to again integer. So that is the solution of this trigonometric function. Example number 2. That is cos of x plus pi by 10 equal to 0. Obviously it is similar to second formula, because here cos theta is equal to 0 is given. So here we will write, here given cos of x plus pi by 10 equal to 0. Also we know that if cos theta equal to 0, then theta is equal to, we have that formula of all multiples of pi by 2, where n belongs to set of integers. So we will use the same here. Therefore we get here x plus pi by 10 is equal to 2n plus 1 times pi by 2. Therefore x equal to this 2n plus 1 into pi by 2 minus pi by 10. So this will be the solution of this trigonometric, general solution of this trigonometric function, where n belongs to that set of integers. That is also important to write. Okay, so this is second one. Let us move towards third, example number 3. These examples are very simple. Let us see different one. Sec x equal to root 2. Example number 3. Sec x equal to root 2. Here this example belongs to second group, because here different constant is given here instead of 0, root 2 is given. So we will write, since given sec x equal to root 2, also we know that, but we will convert this sec into cos. Whenever sec, cosec and tan are given, cot are given, we will convert them into cos, sin and tan respectively. So here sec x is given, therefore, but cos x equal to 1 upon sec x, or sec x equal to 1 upon cos x. Therefore we get here cos x, that is equal to 1 upon root 2. That means we have converted this problem of trigonometric function from sec function to cos function. Now we will see towards this cos x equal to root 2. So we can use formula number 5. But before that, we have to change this 1 upon root 2. As for which value we get cosine ratio as 1 upon root 2, it is for pi by 4. So as cos of pi by 4 is equal to 1 upon root 2, and this pi by 4, it is the smallest principal angle satisfying this equation. There are two angles, out of that this pi by 4 is smaller, so we will consider this. Therefore cos x equal to cos of pi by 4, and you can write this, that pi by 4 is principal angle, or it is the smallest angle. So cos x equal to cos pi by 4. Now this example is converted into this fifth standard result. So this will be cos x equal to cos pi by 4. Therefore using that result, or you have to write here, we know that if cos x equal to cos alpha, cos theta equal to cos alpha, then theta is equal to 2n pi plus minus alpha, where n belongs to integers. This is the formula. Okay, so using this formula we get x equal to, therefore here x equal to 2n pi plus minus alpha. What is alpha? Alpha is our pi by 4 angle here. So we get this, where n belongs to integer. This is the general solution of given trigonometric function. This is the general solution of given trigonometric function. Okay, so it's very simple to write the general solution. In this example, first convert this sec into cos, and you know the minimum value of cosine function or that angle, which gives cos theta equal to 1 upon root 2. So we get pi by 4. So equate these two. Now this is our standard result, similar to result number 5. So using that formula we get general solution. Okay, let us move towards what will be our first step. Whenever sec, cosec or cot trigonometric function is given, then we will convert it into corresponding either sine, cos or tan. Here cosec is given. Since given cosec is equal to minus root 2, so from that you can write sine x equal to minus 1 upon root 2. That is the first step. Now what to do? In our all formulas, left hand side and right hand sides all are given as positive. Here given negative. So we will absorb this negative sign here. For that, first we will find the smallest angle for which this sine function has value 1 upon root 2. We know the sine pi by 4 is equal to 1 upon root 2. As we know that sine of pi by 4 is equal to 1 upon root 2. So we will write here sine pi by 4. Therefore we get sine x equal to minus of sine pi by 4. But we don't need here negative sign, we want here positive sign. So we will, where sine function is negative, it is negative in third and fourth quadrant. So we will use that formula related to third quadrant, that is sine of third quadrant means pi plus pi by 4. Now sine pi plus pi by 4, it will be 5 pi by 4, and sine 5 pi by 4, write this as sine 5 pi by 4. Now this 5 pi by 4 here, and this 5 pi by 4, it is the smallest angle or principal value of this function which gives this solution. So this 5 by 4 is the principal solution first, and using this smallest principal solution we will now find the general solution. Now therefore also if now this sin x is equal to sin theta, so this will be of type 4. So here if sin theta is equal to sin alpha, then it implies sin theta is equal to sin alpha, it implies theta is equal to n pi plus minus 1 raised to n into alpha, where n belongs to integer. Okay, therefore here we get from this equation we get x equal to, x means theta equal to n pi plus minus 1 raised to n into, here alpha is 5 pi by 4, where n belongs to integers. So that will be the general solution. Okay, let us once again see. Whenever cosec is given, we have converted it into sine function. Then find first this positive number 1 upon root 2. Just see only 1 upon root 2, that constant. For that find trigonometric function. So we get sin pi by 4. Write that instead of 1 upon root 2 sin pi by 4. Now absorb this negative sign in the bracket. So pi plus pi by 4. We get 5 by 4. Obviously it will be principal solution of this trigonometric function. So using that principal solution, now we will generalize the solution so that we get here general solution of this trigonometric function. Okay. Cos 3x equal to 1 upon root 2. Again we can write here, since given first cos 3x equal to 1 upon root 2, we know the angle for which cos becomes, or cos has value 1 upon root 2, and that is nothing but cos of pi by 4 is equal to 1 upon root 2. So we will write instead of 1 upon root 2 we will get cos that. So from these two equations we get cos 3x equal to cos of pi by 4, and this pi by 4 is principal solution of this. Therefore for angle 3x, so here we get cos 3x equal to cos theta. So use this again, formula number 5, and from that we can write directly. Using that we get 3x equal to, 3x means theta is equal to n pi plus minus 1 raised to n into alpha. Alpha is nothing but pi by 4. So x equal to n by 3 into pi plus minus 1 raised to n into pi by 12, where n belongs to set of integers. Don't forget to write that what is n. N is integer. So this is the general solution of this given trigonometric function. Okay, it's again simple. Just don't bother about this angle 3x, whether it may be 3x, 5x or 10x. No problem. Only just find the value of trigonometric ratio, trigonometric function, for which we get value as 1 upon root 2. So it is cos pi by 4. So we get here cos theta equal to cos alpha. Using this formula number 5, we get this. Using result 5, we get this. Okay, let us move towards next one, upon root 3. Here first convert this cosec into sine, so that we get here sine 2x is equal to minus root 3 upon 2. You know the angle for which sine ratio is root 3 upon 2, obviously, but sine of 60 degree, that is pi by 3, is equal to root 3 upon 2. That we know that sine pi by 3 equal to root 3. Just put that value here. Therefore, we get sine of 2x is equal to minus sine pi by 3. And we got this first stage of this solution. Let us suppose this as first stage. In first step, we convert this cosecant into sine, and we will write the trigonometric function here for this value root 3 upon 2. Now we will absorb this negative sign. Where sine function is negative, it is negative in third and fourth quadrant. Third quadrant means pi plus. So we will write this as sine pi plus pi by 3. Pi means no change in trigonometric function, and pi plus means third quadrant. So in third quadrant, sine function is negative. So we get this as negative of sine pi by 3. So it is equal to sine of, this will be 4 pi by 3, and this is the principal solution of this function, for which this 4 pi by 3 is principal solution, and we satisfy that given trigonometric function. Therefore, here we get sine of 2x equal to sine 4 pi by 3. Now it is similar to our formula number 4. It is similar to formula number 4. So, using result, you write that result here. Result number 4, we get, or we can write 2x equal to, first result is, it is n pi plus minus 1 raised to n into alpha. Alpha is 4 pi by 3, where n belongs to integer. Therefore, we want solution of this trigonometric function. Solution is nothing but the value of variable x here, not value of variable 2x. 2x is not variable, only x is variable. So, in last step, we will divide each term by 2. So, we get here n pi by 2 plus minus 1 raised to n into 4 pi by 3 upon 2. So, we get here, that is 2 pi by 3, where n belongs to integer again. Okay, right, trigonometric function here, trigonometric function is sine square x, and it is equal to 3 by 4. So whenever square is given, don't take square root of both sides. Write this in the form of square, so that we get here, this is nothing but root 3 upon 2 brackets. We got this first step. What to do? First, write this trigonometric function and the right side in the form of square. We know better the trigonometric value angle for which sine ratio is root 3 by 2. We know that. Sine of pi by 3, that is sine 60, is equal to root 3 upon 2. So put this value of root 3 upon 2 as sine pi by 3 in this equation. Therefore we get sine square x is equal to sine pi by 3 its square, that is nothing but sine square pi by 3. Is it okay? So we get sine square x equal to sine square pi by 3. Means here alpha is equal to pi by 3. So see this result. Where is it? It is in result number 7. So, but sine square theta is equal to sine square alpha implies theta is equal to n pi plus minus alpha, where n belongs to integers. You know this result. Therefore, we get here theta means our x is here. So x is equal to n pi plus minus alpha. Alpha is pi by 3, where n belongs to integers. So you can take common I also from these two, or you can keep as it is. So it is n plus minus 1 by 3 into pi. So putting the values of n, we get different solutions of this. So this is the general solution of this example number 7. Example number 9. Sin mx plus sin nx equal to 0. Once again, here we have given addition of two trigonometric functions sin and sin. So we can write, since sin mx plus sin nx equal to 0, therefore this can be written as sin plus sin, that is 2 sin cos. So we get here 2 by factorization formula, sin mx plus nx upon 2 into cos mx minus nx upon 2 equal to 0. Is it okay? Have you got this step? Here sin plus n is given, so formula is 2 sin cos, addition upon 2, difference upon 2. So we get this. Again dividing by 2, this 2 will get cancelled. Simplify this. Therefore this is the multiplication of two trigonometric ratios, and their multiplication is 0, so one of them will be 0. So sin of here mx plus nx, we can take common x, so we get n plus n by 2 out of bracket x also, taking x common outside the bracket, into equal to 0, or cos of n minus n upon 2 out of bracket x equal to 0. Product of these two is equal to 0, so either this or this will be 0. Therefore, now again sin theta is equal to 0, so use formula number 1 or result number 1, that sin theta equal to 0 implies theta equal to n pi. So here theta is n plus n upon 2 out of bracket x is equal to n pi. Or you can take here, instead of capital N, you can take n1, because already n is here, so take different constant here, and this cos x equal to 0 means this formula, so we get here n minus n upon 2 into x equal to 2n plus 1 times pi by 2. Here take integer as n2, so these n1 and n2 are integers, where n1 n2 belongs to set of integers. Okay, what we have used here, sin theta equal to 0 and cos theta equal to 0. Result number 1 and 2 is equal to results, we give this. Therefore here this x equal to n1, taking this 2, so 2n1 upon n plus n, that is given m and n in the question, and we get here between pi. Or here, or x equal to, taking this multiple, so this 2 will be cancelled, so we get here x equal to twice n plus 1, not n, n2 upon n minus n, multiple is only pi, because 2 get cancelled, 2 get cancelled. So these are two solutions, first and second, where n1 n2 belongs to set of integers. Example number 10, it is looking lengthy but very simple. Just observe carefully that this 2 sin x is present here also, 2 sin x, and this 2 cos x is also present here, 2 cos x. So just take common 2 sin x from first two terms, so that we get 2 sin x in bracket remains now 2 cos x from these two. From this we get 2 cos x, and we have already taken 2 sin x, so plus 1. These are our first two terms. Our remaining two terms are as it is, that is 2 cos x plus 1 equal to 0. So we can take common now these again. Therefore remains 2 sin x, this plus 1 from that term, and in second bracket we get common 2 cos x plus 1 equal to 0. So here we get now factors of this given equation. One factor is 2 sin x plus 1, second factor is 2 cos x plus 1 equal to 0. Now the product of two factors is equal to 0. It means either first is 0 or second will be 0. So therefore 2 sin x plus 1 equal to 0 or 2 cos x plus 1 equal to 0. This gives us sin x equal to minus half, and this gives us cos x equal to minus half. For which angle sin ratio is half? It is for 30, means sin x is equal to minus sin pi by 6. Sin pi by 6 equal to half. Absorb this negative sign. We have already solved this example. Similar example. Here sin function is negative in third quadrant. So we get here sin of pi plus pi by 6. It is negative in third and fourth quadrant. But third quadrant angle in third quadrant is smaller than angle in fourth quadrant. So we will always select smaller. So in third quadrant pi plus pi by 6. And it is equal to sin of 6 plus 1, that is 7 pi by 6. So we get here sin x equal to sin alpha. Obviously sin x equal to sin alpha, formula will be number 4. So we will write here result, or you can write that result in bracket, that is sin theta is equal to sin alpha, then theta is equal to n pi plus minus 1 raised to n into alpha, where n belongs to integer. This is our result. So we get here, therefore x equal to, here instead of theta we have x, so x equal to n pi plus minus 1 raised to n into alpha. Alpha is 7 pi by 6, where n belongs to integer. Okay, now we have another trigonometric function. That's why we will take here n1. Okay, let us move towards second case. Now, similarly, what do we get here? For which angle cosine ratio is half? That is cos x equal to minus cos of pi by 3. That is cos 60 equal to half. So we get this. Where cosine ratio is negative now? Cosine ratio is, so it is cos of pi minus pi by 2. Is it clear? Whenever pi is here, no change in trigonometric ratio, and pi minus pi by 3 means it is in second quadrant. In second quadrant we get negative cosine ratio. That's why negative, and this pi by 3 as it is. Now, next step we get cos x equal to this, that is cos x equal to cos of, this is 2 pi by 3. Now use the result. Which result is here? Which result you will use? Result number 5, that is cos theta equal to cos alpha. Therefore theta is equal to 2n pi plus minus alpha, where n belongs to theta integers. Okay, so using this result we get, instead of theta we have x. Therefore we get x equal to 2n pi plus minus alpha is 2 pi by 2. But we have two general solutions here. So here we have used integer n1. Let us consider this integer as n2, where n2 belongs to set of integers. So this is our first general solution, and this one is the second. So these are the results or solutions of this trigonometric equation. This example number 11. Sin 2x plus sin 4x plus sin 6x equal to 0. What we do? We will take these first and last terms together here. So we get sin 2x plus sin 6x plus sin 4x equal to 0. Why? Because if we use formula, factorization formula for these two functions, then we get here this as sin plus sin is 2 sin cos plus 2 sin 2x plus 6x upon 2 into cos 2x minus 6x upon 2, or we can write 6x minus 2x because cos function is even function, so we can take either plus or minus, there will be no any change. And the last term is as it is, that is sin 4x equal to 0. Okay, again if we simplify this, we get 2 sin of 2x plus 6x 8x upon 2, that is 4x, into cos of 6x minus 2x is 4x upon 2, that is 2x, and cosine is negative, even function, so we get cos 2x plus sin 4x equal to 0. Therefore, now take common sin 4x from these two terms, so that we get here sin 4x in bracket 2 cos 2x plus 1 equal to 1. This is 2 cos 2x, from that remains 1. Therefore, now we have the multiplication of these two. This is one factor, this is another factor of this multiplication. So each factor will be 0, so that we get sin 4x equal to 0, or cos 2 cos 2x plus 1 equal to 0. Okay, result also here. First, sin theta equal to 0 implies theta is equal to n pi, where n belongs to integer. This is the result for this trigonometric function. So for this, we get 4x equal to n pi. Therefore, x equal to n pi by 4, or n by 4 into pi. But remember that here we have two trigonometric functions, so consider this as integer n1, so that n1 belongs to 0. Okay, now let us move towards this second part. Now in the second part, 2 times cos 2x plus 1 equal to 0, therefore we get here cos 2x equal to minus r. And already we have solved this type of example. Therefore, I will write here cos 2x equal to minus. For which angle cosine ratio is half? It is for cos of pi by 3, that is cos 60 is equal to half. Where cos is negative, it is negative in second quadrant, so it is equal to cos of pi minus pi by 3. So it is equal to cos of 2 pi by 3. So here we get cos 2x equal to cos 2 pi by 3. Now cos theta equal to cos alpha. Using result number 5, we get theta equal to twice n pi. Therefore, using that result, we get 2x equal to twice n pi plus minus alpha, that is plus minus 2 pi by 3, where alpha is equal to 2 pi by 3. Where here we have considered integer n1, now we have considered integer n2. So where n2 belongs to set of integers. Cancelling 2 from each term, we get x equal to n2 pi plus minus pi by 3. So this is the general solution, and this one is. So these are two general solutions for this equation, trigonometric equation, sin 2x plus sin 4x plus sin 6x equal to 0. X equal to tan x minus sin x plus 1. Once again, we are observing the similar trigonometric equation sin x, tan x, tan x. So take all terms to the left side first. So sin x into tan x minus tan x plus sin x minus 1 equal to 0. Now take tan x common from these two terms. Therefore we get tan x in bracket this remaining sin x and here minus 1. Again write these remaining two terms in a bracket, that is sin x minus 1 equal to 0. So it is very much similar to example number 11. Therefore taking sin x minus 1 common, we get in second bracket tan x plus 1, that is equal to 0. Okay, therefore here the product of these two terms is 0. So either first bracket will be 0 or second bracket, sorry, tan x plus 1 equal to 0. This is equal to 0 or plus. Therefore this gives us sin x equal to 1, sin x equal to 1, for which angle sine ratio is 1, it is for sin x is equal to sin pi by 2, because sin 0 is 0 and sin pi is 0, sin pi by 2 is 1. This is the smallest angle for which sin x equal to 1. So sin x equal to sin pi by 2. Therefore sin x equal to sin alpha. Now use result number 4. So using result number 4, so result 4 implies x equal to n pi plus minus 1 raised to n into alpha. Alpha is nothing but pi by 2. So this is one solution where n belongs to obviously set of integers. Let us move towards the second part. Here tan x equal to 1 means tan x equal to tan x plus 1 equal to 0 implies tan x equal to minus 1. For which angle tan is 1? Obviously it's by for pi by 4. Therefore we get here tan x equal to minus of tan pi by 4. Here that tan pi by 4 is equal to 1. Therefore we get here tan x equal to this. Now here tangent ratio is negative. Tangent ratio is negative in either second or fourth quadrant. So between those two we will choose second, because second is smaller. So second means tan of pi minus pi by 4. Second means pi minus. So tan pi minus pi by 4 is equal to minus tan pi by 4, and it is equal to tan of 4 minus, that is 3 pi by 4. So tan 3 pi by 4 is equal to minus tan pi by 4. Now we get here this tan x equal to tan alpha. There is that formula. This formula number 6 implies n pi plus alpha. So here result 6 implies x equal to n pi plus alpha. Alpha is 3 pi by 4. We have two results here, so take n1 here for convenience, and here take n2, where n2 belongs to set of integers. So this one is second solution. Okay, don't think that these examples are difficult. These are very much similar, and within 2 to 3 minutes you will get at least 2, 3 or 4 marks. Root 3 cos x minus sin x equal to 1. Okay, this is different type of example. Here the coefficient of this sin x is 1 given. So if you divide each term of this equation by 2, then this can be written as root 3 upon 2 into cos x minus 1 upon 2 into sin x equal to half. So here, if you consider this as sin alpha, this root 3 upon 2, if you consider this as sin alpha, then let us see a rough figure here. If this is alpha, then it will be root 3 upon 2. Obviously this will be 1, but at root 7 we can write 4 square minus 3, that is 1, so we get this side as 1. So in this figure, if you consider this angle, then cos alpha, sin alpha will be root 3 upon 2. In this figure we get sin alpha is equal to root 3 upon 2, and if you find cos alpha, then it will be adjacent upon hypotenuse, that is half. Is it clear to you? If you consider this ratio root 3 upon 2 related to sin, then remaining ratio will become cos alpha equal to 1/2, that is this second result, second constant. Okay, so let us use this here so that this equation becomes, this is, consider a triangle, you can write this one, consider a triangle ABC, you can give any name to the triangle such that this, therefore we get sin alpha equal to 3/2 upon this. Therefore here we get root 3 upon 2 means sin alpha into cos x minus half means cos alpha into sin x is equal to half. Now here formula is sin cos cos sin, so it is related to sin, so take the sin ratio whose value is half. So here we will write that sin pi by 6. So sin pi by 6 equal to, why we have chosen sin? Because in next step we will get sin to the left, that's why we are using sin ratio for this value half. Therefore here this is sin alpha cos x minus cos alpha sin x, so we get here sin of alpha minus x equal to sin pi by 6. Is it okay? It is sin of alpha minus x. Therefore now sin theta is equal to sin alpha, so formula number 4 we can use. So formula 4, result 4 implies alpha is theta is equal to, theta means alpha minus x is equal to n pi plus minus 1 raised to n into alpha. Alpha is pi by 6. Okay, that is our result. But what we want? We want here value of x, which is negative here. So take it to the right, take all this to the left, so that we get here x equal to alpha minus, alpha is alpha minus n pi minus 1 raised to n into pi by 6. From this here root 3 upon 2, so alpha will be root 3 upon 2, so the value of alpha will be here Here sin alpha is equal to root 3 upon 2. So alpha is equal to 60 degree. 60 means pi by 3. So this alpha is nothing but pi by 3. You can use here sin pi by 3, sin pi by 3, sin pi by 3, pi by 2, pi by 3. So that we get here this as pi by 3. Because alpha is equal to sin alpha equal to root 3 upon 2. So alpha is equal to pi by 3. So this will be general solution where n belongs to set of integers.